Hi all. Now we are going to discuss about the MOSFET switching characteristics. So we have already discussed the VI characteristics and the transfer characteristics of a power MOSFET. So now we are going to talk about the power MOSFET switching characteristics. So coming to the power MOSFET switching characteristics, before starting the characteristics, we have to know about all the parameters what we are going to have in this. So first we are going to talk about the turn on time. So actually the total turn on time is going to be divided into two portions, that is turn on delay time, which is going to be TDN, and the raise time TR. So the turn on delay time. So at turn on there is an initial delay, the TDN, during which the input capacitance charges. Actually here the switching characteristics are going to be depend upon two main aspects. So one is the internal capacitance, which is going to be considered for the case of the device, and another one is the impedance of the device. So now here, so the switching characteristics are going to be explained by considering the capacitance charging and discharging conditions. So now coming to this case, so first we are going to consider actually when we want to turn on the MOSFET, so we have to reach the threshold value. So here that gate to source threshold value is going to be represented with VGST, and the gate to source peak voltage is going to be represented with VGSP. So actually the time taken for the device to reach from 0 to the threshold value is going to be called as a delay time, and from the time taken to reach from threshold value to the gate source peak value, that is the device where actually enter into the on state. The VGSP is the voltage at which actually the MOSFET is going to be enter into the on state is going to be called as an VGSP. So the time taken between these two constraints is going to be called as an the raise time. And during this TR, the drain current rises from 0 to full current ID. So now the totally the T on time is going to be considered as TDN plus TDR. So that is the non-delay time plus raise time. So now coming to the off time. So as MOSFET is a majority charge device, the turn off process is initiated soon after removal of the gate voltage at the time of T1. So it is divided into again two portions, which was given by turn off delay time TR and the fall time TF. So which is a off time. So now coming to the turn off delay time, so it is the time during which the input capacitance discharges from the voltage of the V1 to the VGSP, and the turn off fall time, so it is going to be given, so it is the time during which the input capacitance discharges from VGSP to the threshold voltage. During turn off time, the drain current falls from ID to 0. So when the gate to source voltage is less than the threshold voltage, MOSFET is turn off completely. So and these are very popular switch mode power supply devices, so which we are going to use in the SMPSs, and which are going to be having a rating of 500 volts to 140 amperes, right? So now we are going to see about the characteristics of a switching characteristics of a power MOSFET. So this will represent the switching characteristics of a power MOSFET. See here, so this was the gate voltage what we are going to apply. So this is the magnitude of the V1, that means gate pulse V1 voltage. So for a time of T1. So for a time of T1, we are supplying the gate voltage. So now in this time, so what is, how our voltage is going to be raised and all those things we are going to see here. So now see, first the time taken to reach from this 0. So actually this was the 0 portion. So 0 point, so the time taken to rise from this 0 to this VGST. So this VGST is nothing but the gate to source threshold, and this VGSP is nothing but it is the sufficient voltage to drive the MOSFET into the on state, right? So now this time taken from 0 to reaching the VGST, being it was a capacitance, it is going to be shown in a charging portion when we supply the voltage. So now this is the voltage which is going to be raised to threshold. So this is the turn on delay time, and after reaching this, again the time taken for the device to make the device the MOSFET on is from VGST to VGSP, so which is going to be a rise time. And then after reaching this, the device enter into the on state and reaches a peak value of V1, and during this portion, so we are going to have the ID current slowly increases. See here, so from 0 to turn on delay time, we don't have any sort of the current. Why? Because so here VGST is the point where we are going to have starting of the voltage. కాబట్టి మనకి ఇక్కడ 0 నుంచి TDN వరకు ఎలాంటి వోల్టేజ్ని మనం కన్సిడర్, ఎలాంటి కరెంట్ని మనం అబ్జర్వ్ చేయం. బట్ VGST నుంచి VGSP అండ్ V1కి వెళ్ళేసరికి స్లోలీ ద కరెంట్ వాజ్ రైజింగ్, అండ్ వెన్ దిస్ రీచెస్ టు V1, ఇట్ రీచెస్ టు ద current of ID. See here. So now after this T1 pulse, so after the T1, what we are going to do was we try to turn off the device. So when we remove the gate pulse, what happens was slowly it starts discharging. So when the voltage falls from V1 to VGSP, maximum value to the VGSP is going to be the turn off delay time, and from turn off delay time, when it reaches from VGSP to VGST, it is going to be called as an turn off time TF, T off time TF. So now again after reaching this point, it is slowly go down to 0. So in the same way here, so we are going to have a falling of the current from maximum value to the 0 value. So this combination of the turn on delay time and the rise time is going to be called as an on time, and turn off delay time and the turn off time is going to off time is going to be called as an turn off time, right? Thank you.